All right, so systems of equations. Not really anything you need to write down on this page. Just kind of listen for a second. So a system of equations, and we're going to right now be dealing with linear systems, meaning everything we're graphing is a line, is two lines or more, potentially, and we're trying to find the point or points that those lines have in common. So we're going to graphically solve. Graphically, if I graph two lines, the point they have in common would be the intersection point. That's what we're going to be hunting for. And then we'll also do it algebraically without having to graph as well, okay? So the first thing we're going to review, and we reviewed this already a little bit in the 2-3 lesson last week, is just graphing lines. Okay, now both of these lines are already in slope-intercept form for you. Remember, if they were not in slope-intercept form, if you needed the slope and y-intercept, you could just get the y alone, which it already is, which is nice. Okay, so for that first equation, what is my slope? And what is my y-intercept? 3. So if I'm going to graph it, what do I do first? 3 on the y-axis, and then 2/1, and we're going down. Yep. There's my first line. Okay. Second line, what's my slope? 3. Y-intercept 5. Y-intercept first, 1, 2, 3, 4, 5. Slope of 3 of 3/1. There we go. And then the point of intersection is the point that they have in common. Now this one's a little tricky. This is why graphing is not an excellent method unless you're using technology. It looks like it's hitting somewhere between two of my grid lines. So it's hard to get an accurate answer just from this picture alone. I'm going to guess it's about -0.5 and 3.5. But I'm going to show you how to do it in your graphing calculator real quick if you want, so you can check it. So get your graphing calculator out. Have you guys all used Desmos, by the way, before? Okay, so if you wanted to, you could do this on your homework if you want to check answers before you put them in the Math Excel. You can graph any type of line in Desmos, which is nice. And then Desmos, you can actually just click on the intersection and it'll tell you the intersection. Now, tests and quizzes, you're not going to have Desmos, but it's an option if you want to check your work when you're working at home, okay? So in the graphing calculator, I want everybody to go to y equals. I'm going to get mine up here. Maybe. It's going to take a minute. All right, so go to y equals, clear out anything that's in there. And my plot is on. Yours may or may not be because we did that scatter plot last week. We don't want to plot a scatter plot right now, so I'm going to turn it off, go up, hit enter, go back down. So nobody's plot should be highlighted. And we're just going to type both our equations in. So the first one was -2x plus 3. And then the second one was, I think it was 3x plus 5. Does that sound right? Okay, -2x plus 3, 3x plus 5. Make sure when you're hitting an x, you're using the one that's next to the alpha key. All right, and then we're going to graph. If you don't see it immediately, you might be in a weird window. Zoom 6 will always take you back to your normal window. And then you can see that picture that we just graphed on the graph a second ago. Anybody not able to get both lines to show up or not able to see the picture? We're all good? All okay? Yep. Okay. All right. So we're going to ask the calculator now to find that intersection. We think it's around -0.5, 3.5. So to do that, we're going to hit second trace. So this is the calculate menu we're going into, second trace. And then we're going to choose number 5, intersect. So just hit number 5. And then it's going to ask you 3 questions at the bottom. We're just doing basic lines, 2 lines, 1 intersection. So you actually don't even need to right now worry about that. All you have to do is hit enter 3 times. Enter, enter, enter. Enter, enter, enter. And the graphing calculator should tell you the y is -0.4 and the x is 3.8 at the bottom. Everybody able to get that? Okay, so we were close. Our graph wasn't perfect. This is the exact answer. So I'll go back and I'll put that on my lesson. Okay. Any questions graphing or using the graphing calculator to find an intersection? No. Okay. So most of the time you won't have a graphing calculator, and most of the time we are not going to be graphing by hand either, so we don't use this a ton, but it's a nice kind of visual of what we're going to be calculating in this lesson. Okay, so I think we can skip this. I think we're good graphing lines. We're going to move on. All right. 3 things can happen when you graph 2 lines. Number 1, they get an intersection, like our previous example. Number 2, they could be parallel lines, so they could not intersect at all. And number 3, they could be the exact same line, so they are always intersecting. They're always on top of each other. You need to know this terminology that I'm highlighting here. Okay, so write that down at minimum here. So case number 1, intersection, one intersection point. We call that system of equations, those 2 lines, consistent and independent. Okay, so if we have one solution, consistent and independent. If we have no solution, which is parallel lines, no intersection, it is an inconsistent system. And if we have the exact same line on top of itself, they are always intersecting, and we say consistent and dependent. As far as like solving goes, if you get parallel lines, we're just going to say no solution. Usually this symbol, 0 with a line through it. And then if they're the exact same line, we say infinitely many, which usually we just write like this. Okay, meaning not every point in the world is a solution. We don't want to say all real numbers because I can't plug any point in and it work here. It is only the points on that line that work, which is why we don't say all real numbers. We only say infinitely many. There are an infinite number of them on that line. Is this starting to ring a bell? Maybe? Some of you are like, no. Not in algebra 2? Yeah? Okay, so if you're solving by graphing, you know they're going to be parallel if they have the same slope. You know they're going to be the same line if they're the same slope and the same y-intercept. So you should be able to look at the equations as long as they're in the same form and say at least which of these 3 cases it is. Okay. All right. Any questions there? Okay. So ideally, we don't want to have to graph. It's not ideal. It's not going to give us exact solutions. It's not very pretty. It's kind of tedious. We don't necessarily have our graphing calculator all the time or Desmos. So in order to get an exact answer, we're going to use one of 2 methods, substitution or elimination. So we're going to review substitution first. The steps are at the top. If you want to write them down, I promise you have done this before, but if you need a refresher, the steps are there, okay? So this is what our systems are going to look like. It's going to be 2 linear equations, lines that are connected with a bracket. Our first step, if we are using the substitution method to solve, is to get a variable alone. It doesn't matter which variable, it doesn't matter which equation, just get one variable alone. So typically we use this method when one of our variables doesn't have a negative or a number in front of it. Those are easy to get alone, okay? Once I've isolated a variable, I'm going to substitute what that variable is equal to into the other equation. So we're plugging something from one equation into the other equation. If you're doing that correctly, it should be either all x's or all y's, all the same variable at this point, which you should be able to solve for that variable then. Once you solve for one variable, we're going to take that answer, plug it back into one of the original equations to get the other part of our answer. Remember, solutions are points, so you need both an x and a y to have a complete solution. If you want to check it then, you can plug both your x and your y into both equations. It works if it works in both equations. If it doesn't work in both equations, you have not found the correct solution and you want to go back and check your work. Okay. All right, so let's do this example. First equation is x minus y equals 5. Second one is 2x plus y equals 7. So first thing I want to do is get one variable alone in one of the equations. So if I'm looking at this, I'm going to say either probably that x on the top equation or the y on the bottom equation. Don't have anything in front of it. Pretty easy to get alone. Does anybody have a preference? You can do it either way. No? Okay. I'm going to get the x on top alone. So if I get the x on top alone, all I have to do is add y to the other side. So x equals 5 plus y. That's all you have to do for the first step. Sometimes that'll be done for you already. Second step is whatever that variable is equal to, in this case 5 plus y, that's telling us that it's the same thing. X is the same thing as 5 plus y. So I can take 5 plus y and replace the x in the other equation with that. So I'm going to take the x out. Make sure you put a parentheses anytime you're plugging something in, and replace it with what we know it's equal to. X is the same thing as 5 plus y. Plus y equals 7. Bring everything else down. So at this point, you know you're on the right track if it's all y's or all x's. Now we solve just linear equation. I'm going to distribute my 2. 10 plus 2y plus y equals 7. I'm going to combine my like terms. 10 plus 3y equals 7. Subtract 10. 3y is negative 3. Divide my 3. Y is negative 1. So as far as my final answer, my point goes, I know my y coordinate now is negative 1. At this point, you can plug that back into either of the original equations as recommended. You could plug it into this 5 plus y too if you want to, as long as you know you did that right, you're okay. So I could say 5 plus negative 1 is equal to x. So x is equal to 4. And then that's my answer for negative 1. I'm just going to show you one time how we check these answers. Helpful on a quiz or a test. I'm going to plug 4 in for all of my x's. I'm going to plug negative 1, bless you, in for all my y's. So that's going to look like 4 minus negative 1 equals 5 on the top equation. On the bottom equation, it's 2 times 4 plus negative 1 equals 7. And your job is just to make sure those are both true statements. Does 4 minus negative 1 equal 5? Yes, it checks. Does 2 times 4 plus negative 1 give me 7? Yes, it checks. So that's all you have to do to check your answers. Just plug them back in, make sure they both work. Okay. Any questions on substitution? Okay. All right. With your partner, try these two. Solve using substitution. And if you want to check it, load up Desmos, so just plug your answers back in. Correct answers are in red at the bottom. First one's a little messy. 12 sevenths and negative 9 14ths. You might not have solved it the exact same way I did. That's not bad. But I would say these are typically the paths of least resistance, because the x in this equation and the y in this equation are the easiest to get alone. If you get something else alone, it's fine, but you're going to end up with fractions, and it's going to get real messy. Make sure in this step, you're distributing the negative 4 through. That's a common mistake. People only distribute the 4 through and then mess up their signs. Questions do we have on this? Okay. All right, there's one other method we're going to talk about today, then, and that is elimination. This is sometimes called the addition method. And again, the steps are at the top there if you want. This is my preferred method of solving. I don't love substitution. I don't like graphing at all. Elimination will work even if we don't have a variable that's nice and pretty to get alone. Like this, I would have fractions for sure if I tried to isolate a variable, and it's not amazing to graph either, okay? So in elimination, you want to make sure at the beginning everything's lined up, okay? So we want x's, y's, equal signs, constants, everything in this problem is lined up already. If it wasn't, at the beginning you want to rearrange some things to make sure you've got everything lined up nice and pretty, ready to go for your problem. Okay, so first step, after everything is lined up, is we are going to adjust our coefficients, if we need to, by multiplying through a number or numbers so that the coefficients on the same variable are opposite. So what I mean by that is I'm eventually going to be able to add these equations together. I want, when I add these equations together, for a variable to disappear. I want either my x's to go away or my y's to go away. But what do I have to add together to get something to cancel? They have to be opposites. So like if I had a 3x and a negative 3x, that would be good. Or a 2y and a negative 2y, that would be good. That's the situation we want to happen. If it isn't like that already, we multiply one or both equations by something. So there's lots of different ways to do this. In this specific problem, I could do one of two things. I could multiply the top by a negative 3 all the way through that equation, because then I have a negative 9x and a positive 9x, and I can get them to cancel. Or I could multiply the top by a 2, because then I would have a 4y and a negative 4y, and I would get my y's to cancel. So you can multiply by what you want, as long as you get opposite variables. Then we add the equations together, and a variable goes away, and it gives us our first answer. After that, it's just like substitution. We take our first answer, plug it back in, make sure that we can get the other part of the answer, check it if you need to. So for this one, let's just say I'm going to multiply the top by 2. Okay. If you're lucky, all you have to do is multiply one equation by something. Sometimes you're going to have to multiply both equations by something to get them to match up. You want to stick with multiplying through integers only, no fractions or decimals. It's going to get messy if you do that. If I multiply everything in the top equation by 2, notice I put parentheses around there, so I remember to distribute it all the way. I'm going to get 6x plus 4y equals 6. And then I can add my equations together. So just add down the columns. This is why we want everything lined up. 6x and 9x give me 15x. If you're doing it right, variables cancel. 4y and negative 4y gone. 6 and 4 give me 10. And you can see now it's just a one-step equation to solve for x. If I divide by 15, I have 10 over 15. What does that reduce to? 2/3. Keep it as that exact fraction. Once you have one answer, you can plug it back into either equation to get your other one. Let's say I use my top equation. 3 times my x is 2/3 plus 2y equals 3. 3 times 2/3 is 6/3, or 2 plus 2y equals 3. Subtract 2, I get 1. Divide by 2, I get 1/2. Final answer, 2/3, 1/2 is my point of intersection, my solution to the system. Okay? Any questions? Will we ever have to do, or will we always have choice? There might be one on the quiz that specifies the method, and there might be one graphing coming up like middle of next week. But test time comes around, it'll just say in general solve, and you can solve using whatever method you prefer. Okay. Math Excel, same thing. Math Excel will say substitution, elimination. Likely they're giving you the method that is the easiest to solve for, but on your paper, if you do it another way, and as long as you get the answer, you're fine. Okay, just not with decimal. Try to do it on your own. All right, so with your partner, last 2 problems of the day, I want you to solve these using elimination, and everything's lined up for you nicely already. So remember, your first step here is you're going to multiply one or both equations by a number, so you get opposite variables, add them together, get one solution, plug it back in to get the other part of the solution. Okay?
Yeah.
Okay. If you're not ready, don't look. Answers are at the bottom. So on the top one, I multiplied just through a -3. Make sure I had opposites. The second one's a little tricky because you can't just multiply an integer through and get those opposites. So the easiest thing to do, if you're not sure what to multiply by, take two numbers that are in front of the same variable, like just 2 and 3, and flip them. So if I multiply the top by 3 and the bottom by 2, in both ones I'm doing 3 times 2, so I guarantee I'm going to get the same number. Just make sure that one's positive and one's negative. If they aren't, you might have to multiply a negative through one of the equations to make sure you get opposites. Okay, but that's not the only way to do it. Like I could have multiplied the top equation by 7 and the bottom by 3. Would have also worked. I want to warn you when you're doing your homework, you might see the no solution, infinitely many solutions pop up as you're doing this. If when you are solving and you get something like the following, all the variables go away and you are left with 7 equals 7 or 0 equals 0. If you're left with just a number equals itself and no variables left, that tells us that we have a true statement, that those are always intersecting. The equation is always true. So this is the infinitely many case. At that point, if all your variables go away and you're left with a true statement, it's infinitely many. If you were to graph it to check, you would see that they are the same line. If you end with a false statement, like 0 equals 3, all the variables go away, that tells you that there is never an intersection, and that's our no solution case. So that's actually parallel lines. If you were to go back and look at the graphs of those equations, you would see that you have parallel lines, same slope. Okay, so if that happens as you're solving, it's not bad. It just means you have one of those special cases, and if you're not sure, you can think about what those graphs would look like. Okay, we're going to stop there for today. Tomorrow we'll wrap up this section. We'll do a couple problems that have fractions in them, a couple word problems, and that'll be it for section 8.1. All right, so we'll do cell phone lotto here for you, and then you guys can work on homework the rest of the period.